I'm Bob from Hauptwerk Hardware, and in this video I'm going to talk about the System 1 power management features. But first, let's take a look at what I mean by power management and why we might want to use it. In the case of a virtual organ, it's always going to be the case that the sound generation and visual representation, if used, is generated by a computer of some sort, running virtual organ software of some sort. The usual setup that comes to mind is a PC running Hauptwerk software. But there are other alternatives, and I've tried to design System 1 so that it can be helpful in as many different setups as possible. So if we look more closely at our own setup, we can agree that there are a number of computers involved in the chain between you, as the organist, pressing a key, and the resulting sound coming out of the loudspeaker or headphones. The controls on the console are being scanned by a computer. In the case of System 1, there are two computers that scan the controls. These computers are clearly less powerful than the PC or Mac that's running Hauptwerk, but they're still computers nevertheless. The main difference between the scanning computers and the PC is the way that the operating system and storage memory is implemented. Crucially, it's perfectly acceptable, and indeed usual, to simply cut the power to the scanning computers when one is finished using them at the end of a session. But this is absolutely not the case with the computer that's running the Hauptwerk or other virtual organ software, and in addition to this, there is a need to save any changes that may have been made to the software, such as registration changes and so on, before shutting it down. So these different needs require the user to initiate a specific shutdown procedure at the end of a session, usually by using a mouse or keyboard to close Hauptwerk and then to click the shutdown option on the PC. If you're using your virtual organ setup at home and you're the sole operator, then this is all perfectly acceptable and expected, and you would have no requirement for any further power management functions as you're fully conversant with the start-up and shutdown procedures of your equipment. Things change though if you have other use cases in mind. For example, if you're building a so-called headless system which is installed in a church or other public venue, then the user or users will expect to simply turn on the power switch when they begin a session and turn it off at the end of a session. This is, after all, what organists have been doing for many years, and whilst it must be obvious to some users who understand the technicalities of modern musical innovations, like virtual organs, many organists, certainly in my experience here in the UK, do not appreciate the difference, and they're not interested in the difference, and regardless of what we may advise, they will continue to use the organ in the same way as they always have done. This inevitably can result in difficulties with virtual organ software and sometimes operating system software misbehaving in response to regularly just having the power removed at the end of a session. This is where the System 1 power management is designed to fit. Operating a single switch turns the organ on or off, but it does not control the power to the computer, but rather mimics the things that a tech-savvy operator would do, namely power the system on, notify the user when the system has completed booting up and the virtual organ software is loaded and ready to play, and keep amplifiers muted during this period, which is not always necessary, but some computers make a heck of a racket as they load the sound drivers with odd pops and bangs which are usually unappreciated by the audience. At the end of the session, the user simply switches the power switch off, and this initiates a saving of any changes, followed by a controlled shutdown of the computer. At the same time, the user is notified that the shutdown procedure has been initiated, as well as when it is complete, and that it is now safe to remove the power, i.e. pull the plug from the wall. So how do we achieve this? Firstly, we change the connections to the console power switch so that it is able to be connected to System 1 power management board, and crucially is totally isolated from everything else. This allows System 1 to know whether the power switch is on or off and when it is operated. Secondly, we need to configure the virtual organ software, i.e. Hauptwerk or whatever one you use, so that it will send a MIDI event when all is loaded and ready to use, as well as arrange for that same software to respond to a specific received MIDI event by saving the changes and triggering a PC shutdown. And finally, we need to inform the user when the organ is ready to play and when it is ready to be physically powered off. These various states are communicated to the user by the use of a single bicolour LED. When the organ is first turned on via the power switch, the LED illuminates red. Once the PC is booted and the virtual organ software is loaded and ready to play, the LED changes to green. When the power switch is turned off, the LED goes back to red. And finally, when the PC has finished shutting down, the LED goes out, signalling that it's safe to remove the power plug from the wall. At this point, it's worth mentioning some limitations. This power management arrangement was designed to work with a Raspberry Pi single board computer. This is because that is what I have exclusively used for the organs that I have rebuilt for use in churches. There are a number of reasons for using the Pi, but the major one is that it happily runs sound generation software that can be properly and professionally voiced to match its acoustical surrounding, and we can create any required stop sound that the customer requires. Usually that just means recreating the original lineup that their organ came with. In other words, match the new sounds to the original stop sounds. This is often difficult though when using sample sets or pre-made or recorded organs. But either way, the power management system is designed to recreate something close to the original user experience regarding the use of the power switch. Naturally, this works perfectly when used with a Raspberry Pi computer for which it was made. However, I have found some issues when using this with a regular desktop computer. So, what works and what doesn't? Regardless of which computer one uses, the bicolour LED functionality works just fine. But the issues I've found is controlling the PC's actual power supply unit. The System 1 power management is designed to work with an ATX power supply, and so one would expect that it would work with a desktop computer using a similar power supply, except that it doesn't. I've tried a couple of different computers and got different results. In one case, I even seem to have damaged the computer's motherboard in that it now always turns the power back on again around 10 seconds after it has successfully shut down, even after resetting the BIOS to its safe defaults. So, as obviously there are many different PC models and manufacturers out there, it would be impossible for me to test them all. So I'm going to leave it to you, the installer or end user, to experiment with the power control side of your own computer and to point out specifically that any connections you make to your computer and any experiments you conduct, you are doing so entirely at your own risk. I do not advise experimenting with anything that you're not entirely certain of the outcome with. So I reiterate that any connections you make to your PC motherboard, you do so at your own risk. Bear in mind that the only connections I was using in my experiments were to the power pin where the case switch or the case power switch plugs in, and monitoring the voltage on the ATX pin 16, which is the standby stroke on connector. I imagine though that if you're using a PC with virtual organ software similar to Hauptwerk, you'll almost certainly be using a keyboard and mouse, or possibly one or more touchscreens to control it. So that being the case, you will have no need of the System 1 power management hardware. As I have said earlier, it is only for use when building a headless system, and for this, a single board computer is, in my opinion, the best choice. Anyway, all of that said, let's get to the bench and see how the System 1 power management features can be used. Okay, so I've got our little power management board wired up and sitting on the bench here, and I've made a little mock-up of everything connected together so we can see how this works. But just before we start with that, this is just connected. I've stuck the bicolour LED just across its connections here. Ordinarily, obviously, this would be mounted on some wires and it would be on the front of the organ console. But for the demonstration purposes, it's easy just to plonk it on the board there. And then our other connections along the board, we'll look at those more closely after the little demonstration. But for the moment, as I say, that's just connected up so we can see how this all works. So if I zoom out now, I can show you all of the other bits and pieces that we've got on the bench that are comprising our little organ system. Okay, so this is our management board that we just looked at. This is just a switch, which in this context is just mimicking the switch on the front of the organ console. What I usually try and do with these is to reuse the original power switch that was on the console, because it keeps it looking nice and original. Obviously we remove the mains power and all the other connections from the switch, and it ends up with just two wires. It's just an ordinary on-off switch, and they come back to our power management board to the two contacts marked switch. It doesn't matter which way around they go. So that's what that's about. So normally, as I say, that would be on the front of the organ. The LED would be mounted near it. You know, I normally use a little chrome bezel thing so that it just makes it look nice and neat. So that's what that bit's about. Then we've got the Raspberry Pi over here. It's got a Hi-Fi Berry DAC 8X sound card on top, so that gives us our 8 channels of audio, which is handy when we're working with our organs. We've got 2 USB connections to it over here, the purple or kind of light lilac colour, I suppose, maybe you call that, I don't know. But this is our Turtle Beach USB MIDI adapter that we've used for everything else in this series, the other end of which is connected to our MIDI connectors at the back of the System 1 control board. Which is what this is, obviously. There are a couple of connections to the board, and that's all we're using at the moment because we've not got any keyboards or anything else plugged in. This is simply just to show how the power works. So from the back of the board here, if I just tilt it up to stop the light shining on it, we've got our plus volts and ground power. So this is power coming into the control board. That's what powers it. And then we've got 2 other connections over the back here, which is switch state and ready. And these 2 simply just come round and connect to our power management board. So that's how that works. Then on the right hand side here, to power the whole thing, this is an ancient ATX power supply that's been kicking around the workshop forever. I'm using one of these little breakout boards. You can get these from Amazon for next to no money really, and eBay and places like that. I think they're about £8 I pay for these, but they just make it nice and easy. You can just plug the thing in and then screw your wires into the connectors for everything else that we're using. So I use these in organs that I rebuild. Also, all of the wires, I like to put these little ferrules on. Again, you can get these really cheaply from Amazon, but what they do, these screw connectors I don't think are the most reliable things in the world, but if we put a ferrule on the end of each piece of wire, then that just makes everything a bit kind of stronger and more robust, and there's no way that that wire is going to pull out. That's fine now. Again, those little kits for doing this, they come with some ridiculous amount, about 12,000 ferrules or something, or maybe it's 1,200, I don't know, there's a lot of them anyway, and quite often they come with the tool for fixing these onto your wires, so they make it look more professional and they make it more robust, in my opinion. So we are only using plus 5 volts and ground here. Those are the only, that's what these connections are. So there's a plus 5 volts and ground going to our control board. There is a little kind of, I guess you'd call it a little USB-C pigtail thing. So if we move those out of the way, that's powering the Raspberry Pi. So we've got a little USB-C connector here that comes round, and then that's just 5 volts and ground is connected to the power supply here. And that's pretty much all that we've got there. We'll come on to this cable in a second. this other USB connector, the black one from the back of the Raspberry Pi, that comes round to our power management system, and the reason that's there is so that the control board via the power management board knows all the while that the Raspberry Pi is powered up. And you could argue, well, it's going to know that anyway because it's getting 5 volts from the power supply. However, when the Raspberry Pi shuts down, it will turn off the USB, which we then sense, and then we use that, the fact that that's happened, to switch off the power supply, because the Raspberry Pi obviously won't directly turn off the power supply. So that's what that USB connection's for there. And then the last connection into the side of the Raspberry Pi here, this is our monitor, HDMI monitor, which wouldn't normally be there in a headless system. Obviously you wouldn't have a monitor, but I've got this plugged in just so that we can see what's happening when it boots up and see what's happening on the screen. So that's going to be hopefully a little bit more helpful. So I think that's enough waffle. I think I've explained what everything is here. So what I shall do now, I'm going to switch it on, and the sequence is there's already mains applied to this ATX power supply, but I shall switch this switch on, and what that will do is it will turn on the ATX power supply. Very shortly after that, once the Raspberry Pi has noticed that the power supply has come on and it's powered up its USB, then this LED will light up red, and then that will stay red whilst the thing boots up, which we can look at on the screen via our little HDMI lead we've got plugged in here. And then when everything's ready, the LED will go green. So if I switch that on now, the power supply started. A couple of seconds later, so this LED's gone red now, and it's starting to boot up. And if we look at the screen, we can see it's a little splash screen there, just showing us that it's getting going. And it takes a few seconds for the operating system to load, and then for our organ softwares to load. So that's the whole point of this red light, because at this point, if the organist thought he'd turned it on and he could start playing, he couldn't, because it hasn't finished loading yet. You can see it's loaded Aeolus, it's just starting to load J organ, but basically we have to wait for this to go green, which it will do shortly. So there we are, it's gone green. So the organ's now ready to play. If you look at the screen, we've got our representation of J organ on there. Obviously we haven't got any keyboards or anything connected, so we can't play it, we can't make any sound, but this shows basically what's happened or what's happening. So that's the startup procedure, and as I say, once the LED's gone green, the whole thing now is just ready. You can play that all day long, not a problem at all. When the LED went green, I don't know if you noticed, there was a tick, and that was this relay switching over. And this relay is connected to these three solder pads at the back. There's a common, a normally open and a normally closed. They're just dry contacts, meaning they don't have any voltages or anything else on them. And we can use those for amplifier muting or pretty much anything else that you want to control once this is booted up. So that relay switches over when the LED goes green. So when it's ready to play, relay switches over. You can use that for whatever you want. Obviously the whole board here is a low voltage board, so I wouldn't recommend using this for switching any high voltages, but for just trigger inputs, 5 volts, 12 volts, whatever, on these contacts, that'll be just fine, as long as obviously you don't connect anything to any of the other parts of the board that's more than 5 volts. So that's that. If I switch the switch off now, so we say, okay, well, we've got to the end of our session, everyone's walking out the church, the organist is going to go home, he's finished, so he's going to switch off the organ and pretty much walk away. So if I do that, first thing that will happen is the LED will go red, just in case anybody kind of wandered up and thought they played the organ. They can't, because the LED is red, but it's only for a second or so anyway, and then the whole thing will go off. So if I switch that off, the LED's gone red. On the screen you saw the shutdown message come up, and now everything has switched itself off, so the LED's gone off completely, and that's pretty much how that works. And the way that it does it is that the J organ software, and I have tried this with Hauptwerk as well, and it does work with Hauptwerk, at least this part of it does, is that once the software is loaded, it sends a MIDI signal via our USB MIDI adapter here, the Turtle Beach thingy, to our control board. And then when the control board receives that MIDI signal, it basically switches the relay, switches this output, switches the LED to green, and that's how that side of it works. And then when it's time to shut down, and we switch this switch off, again, the switch state pin here will see that change of state with the switch, and it will cause the control board to send a MIDI signal via our Turtle Beach MIDI interface, which will go back to the Pi or Hauptwerk or whatever you're using, and then that will be set up to initiate a save for Hauptwerk or JOrgan or whatever you're using, followed by a computer shutdown. And most of the, well, I say most of, I haven't looked at at Grand Org, but I'm sure that that works the same way. The ready signal, to get that out of Hauptwerk, you can use there's a feature under the organ menu, and in there, if you go into the advanced MIDI, you can select the option which says send a custom MIDI message once the organ is loaded and ready to play. That's what I use for this. So that's how you do it in Hauptwerk. In JOrgan, I've just created a hidden control which is permanently on, and then once the thing's loaded, obviously because the control's on, it will send a MIDI on command, which this sees. So that's how that works. And then the shutdown side of it in Hauptwerk, there is an option that you can choose for a controlled shutdown, preceded by a save of all of the changes that you might have made in that session, and you can get it to do that by receiving a particular MIDI message, and you can obviously set which MIDI message it is, and we'll look at what this creates for those messages in a minute. So that's how the shutdown side of it works on Hauptwerk, and on JOrgan we use just a shutdown button on the screen, and I'll show you that in a moment as well. So that's kind of all the hardware. That's basically the system, how it works. And what I think I'll do now is I'll get all this off the bench, I'll disconnect this, and we'll have a closer look at it just so that we can see what the different connections are. And then we will have a quick look at the things I've just been discussing in the software itself, and what MIDI messages are coming and going to our control board when the power management system is operated. Okay, I've changed the setup on the bench now to make things a bit more simple. We've got rid of the Raspberry Pi, we've got rid of the ATX power supply, so what we have now is our System 1 control board. It's plugged in via this USB serial comms connector. That's what's providing power at the minute, for the board anyway, and the little USB power thing that would normally be connected to the Raspberry Pi, I've just got that plugged into a USB power supply, just to simulate the power that's coming from the main setup, because obviously the power we're putting in here is not going to be seen by the switch and everything else. That requires this power over here. So that's what I've done. I've got the computer up and running with everything plugged in as normal. So we've got our comm session on the right here. This is monitoring what comes out of this serial connection. And on the left we've got our normal MIDI monitoring and MIDI sending arrangement that we've seen before. So let's take a look at what happens. So first of all then, whoops, it falls on the floor, which is not overly helpful, but let's just rescue that. Okay, so we're at the point where we say we're going to power this thing on, and when I do, nothing really much is going to happen, because all this would normally do, as we saw, is pull this control connection, which is not connected right now. This is the green lead from the power supply. Switching this on pulls that low, but also the control board knows that we've switched it on. So if we turn that on now, and we look at the computer, we can see that the control board has seen that, and it says power switch is low, meaning on. But we can also see that it hasn't sent any MIDI. There's no MIDI come out from the board at all. It's just noticed that we've turned the switch on. And the reason for that obviously is we've only just turned it on. So the computer hasn't booted up. It wouldn't know whether we'd sent it any MIDI or not. It would be pointless. And there's no real need to send any MIDI. So at this point we imagine that the computer's happily booting up, and when it's finished booting up, when it's ready, it sends, the Raspberry Pi will send, or whatever computer you've got this on, with Hauptwerk or whatever, it will send a MIDI signal to the control board telling it that it's booted up and it's ready to play. And the MIDI signal in question is on channel 11, and it is note 100. Which happens to be E6 on the keyboard. So if I press this key now, that will send a MIDI note on 100 on channel 11 to our control board, and what that will do is it will cause the LED to turn green. So if I do that now, so I press that down, okay, so you can see the LED's gone green. You heard the relay tick, and you can also see on the screen, I can't point to it with the mouse because I'm busy, whoops, well I was busy holding the key down, but you can see that it said up the top here, aux functions 100 on. So that's the point at which the control board has received that MIDI message, and then when I let go of it, it gave us a 100 off, and as I let go of it, I slid it to the right. That's where we got the 101 on and off, which don't actually do anything. And you can see on the MIDI out monitor there that that it's done that as well. So just to do that again, if I press that, hold it in, you can see that the light goes green, and then when I release it, the light goes red. So this is the bit where your virtual organ software, you configure it so that it sends a note 100 on channel 11 when it's all loaded and ready to play. Okay, and then obviously when it's not ready to play anymore, it will send a note 100 off, which turns the LED back to red. Also, just in case it doesn't, the System 1 control board does that internally anyway. As soon as it sees this switch operated to switch off, it will switch the LED back to red anyway, regardless of whether it receives the MIDI to do that, because it knows now that you're in the shutdown process. So that's that bit of it. So let's go back and look at what happens now from a MIDI perspective when we turn it off, because you'll remember when I switched it on, we said that there was no MIDI sent. So if we come back to the computer and look at that at the top, power switch is low, meaning on, but then the MIDI that we see after that was much later on. That was the 100 for the light to turn green. So when I switch this off now, we'll see on the computer what happens. So there we go, I've turned that off, and it's come up on here that it's sent note on 126 on channel 10, which really means channel 11. It's that 0 and 1 thing that we've been confused about all the way through. Well, I have. And then power switch is high, meaning off. And then it sent a note off 126 on channel 10. So it sends a note on followed by a note off a short time later. The reason for it doing that is that some software requires it to go on and off before it will shut down, and some software doesn't. Hauptwerk, I think, just needs it to go to receive a note on to initiate a shutdown, but JOrgan requires the note on followed by a note off. So just to make absolutely certain it's going to work, it does both. So at this point now, the computer would have shut down, and the power supply would have, well, the USB would have gone off, which is our thing here. So obviously that would be equivalent to that, and the LED would have gone out. And you can see that no more MIDI has been sent now or anything else. So that's basically how the whole power management system works. It just requires 2 MIDI events. One of them is the event to turn the light from red to green and back again, which is note 100 on channel 11. And the other one is to initiate a shutdown of the virtual organ software and computer, and that is note 126 on channel 11 as well. So what I'll do now is we'll have a quick look at the actual board itself. I'll just remove all the wires, and we'll have a kind of a bit of a close-up of it, just so we can see the connections. And then after that I'll have a quick look at Hauptwerk and show you how you would set that up to shut down and to send the signal to change the light to green and all that kind of thing. Bear in mind, as I said before, that I couldn't get the shutdown to work very well with the actual physical computer power supply, and we'll go from there. On the computer side, if we look at our COM session, we can see that it says the controller is ready, so that's good news. And then I'm just starting Hauptwerk over here, the old free edition version 4, and this is set up now so that when the organ is loading, it's ready to play, it will send the custom MIDI message to our System 1 controller, and that you'll see that come up on our monitor screen here, and also it will turn our LED green. So let's have a go at that. We start Hauptwerk up, and just because it started, that doesn't mean you can play it, so nothing's happened yet. The LED is still red. But if we load the organ, which it's now doing, once that has loaded and it's ready to play, then you'll see that it'll send the MIDI message and all will be good. So there we are. So you can see on here, aux functions 100 on. You can see our LED has gone green, and now obviously Hauptwerk is playable and ready to go. So when we are finished, what we can do now, when I switch this switch off, our controller will send our note 126 back to Hauptwerk, and I'm not going to have it shut down the computer because it takes ages to boot it up, but I have configured it so that it shuts down Hauptwerk. And the way you do that, by the way, is that you go to General Settings, Advanced MIDI Applications, and then MIDI key triggers for loading organs and other global functions. And if you click on that, then you've got these options on the side here. So you've got Exit Hauptwerk, which is the one that I've got configured, Shut Computer Down, which I have, and a whole bunch of other things you can do. So that's how that works. So if I switch this off now, okay, so you can see that it's shut Hauptwerk down, it's sent our note 126 on and off, and it's changed our LED back to red. And if that had done a computer shutdown and the power supply had gone off, obviously at this point in time the LED would have gone out completely because there'd be no more power. So that's how all that works. The only bit that I haven't shown you for Hauptwerk, so I'm just going to start that up again, is how you get it to send a specific note on message. So it's under organ settings, there's no organ loaded, so that's grayed out in a minute obviously. So if we load our organ again, we'll see obviously that it will send that note on again, our number 100. So there we go, and it's done that there. But if we go to organ settings and we go from here to advanced MIDI applications, there is the third option down. It says custom MIDI configuration messages to send, and if we click on that, it allows us to add as many as we want. We can do insert or delete for our events on the left, but the way this is configured, I've just given it an alias of power, time to send when audio and MIDI starts, the port to send it to, which is our USB Turtle Beach thingy, and it's a MIDI note on, so it's 3 bytes, and it's 154 tells it it's channel 11 note on, 100 tells it that it's note 100 that it has to send, and 127 is the velocity, which we don't care about. Anything more than 0 and less than 128 will work just fine. So that's how we do that bit. So we can close that, and that's it pretty much for Hauptwerk. I will fire up the Raspberry Pi again and just show you quickly how I've done the same thing in JOrgan. I'm not going to look at GrandOrg because I haven't done it with that. I haven't had any occasion to use GrandOrg with this. Nobody's wanted a headless GrandOrg organ. So let's close this down. We'll get the Raspberry Pi running again and we'll take a quick look at how we do that. Okay, so looking at JOrgan now, we've got the Raspberry Pi back up and running. And the way I've done this is I've got a power off button down here on the bottom right, and if we go into the build view for JOrgan and we select that button, we can see here that it is triggered by the channel 11 note on, note off. That's what these numbers are here. These are MIDI messages, so to activate it we send it our channel 11 note 126, and to deactivate it we send it our note off channel 11 126. So that is equivalent to pressing and releasing the button. And then what that button actually does, its command is just sbin shutdown -h now, so a regular standard Linux shutdown command. So that's how turning it off works. And then for changing the colour of the LED, I have a hidden control. I've just called it hidden ready. It's active is true and the time is infinite, so this is always true, always on. So what will happen is that as soon as JOrgan is loaded, because this is true, the control is on, it will send this MIDI message over here, activated, and that's our channel 11, 154 is channel 11, note on command, 101, so it's note 101, it's that +1 thing again that's been confusing all the way through, so note 100, note 101 in this particular sense, and the velocity of 127. So that's basically how that works with the Raspberry Pi. Okay, so that's pretty much it really. That's how the power management system works and what it can do. But we don't care about that because I said I was going to show you this board, didn't I? So let's do that next. Okay, so here's a close-up of our power management board. Basically, it's got the two connections on the right for the LED plus and the LED minus, and the polarity there, the plus and the minus, is for when the LED is red. So the positive lead to the LED going to the plus and the negative lead to the minus, that will make be the way you need to do it for the LED to be red before it receives the MIDI 100 note on. The next connection across is our ready connection. So basically when this is at logic low, 0 volts, ground, whatever, the LED will be red. When you change this pad here to be 5 volts, logic high, the LED will go green. And that's pretty much all there is to that side of it. We've got a USB plus 5 volts and USB ground. So this is the power that drives the LED in the first place. So you could kind of say that if we cover up the rest of those pins, this side is just for driving the LED. So if you wanted to use this with Hauptwerk or something and you're not certain about actually controlling the power supply itself, you just want to use the LED side, this is all you need to connect to. So then moving along, we've got a ground connection, we've got our switch 1 or switch 2 and switch 1 connections. It doesn't matter which way round they go, but they're the two connections to the switch. And then we've got our on connection, which is connected directly to our system 1 control board, and this is the connection that goes to the switch state connector or solder pad. So if I just grab that for a moment, I can show you. There we are. So we've got these two connections here. We've got ready and power state. So when you connect this up, the ready connector connects to this ready connector on the power management board, and switch state connects to the on connector. And on later versions of this, I'll probably change that on to be switch state, so that, or power state, so that it matches that. So that's that bit of it. And then finally on the far left here, we've got control, and that is the connection to the green wire pin 16 on the ATX power supply. So that's pretty much it really. There's nothing else to say about this. We've covered all of the System 1 interfaces and boards and modules now. So this is almost the last video on System 1. The next video I'll do is just basically looking at how pricing is going to work and various other kind of things, general things about System 1. So that will be the next video in the System 1 series, and that will be the last video for now in the System 1 series. So hopefully you've enjoyed these videos. Hopefully you can use this in your own organs, and even if you've just been watching them to sort of keep up and armchair engineering, that kind of thing, I hope you enjoyed them. So thanks very much for watching.